Hi guys, welcome back to Ox Tools. I'm Tom. We're starting off a brand new project here. Well, not brand new, it's been around the shop for a while. I've been working on some of the bits kind of offline, but it's starting to become a good videoing project, so we're going to shoot some video of it and you guys can follow along. So what it is, just to kind of remind everybody, I'm building a large etching press for my wife. She does printmaking, and this is the hand wheel that operates the press. It's 48 inches in diameter. It's all made out of steel. This particular press, it's basically a glorified clothes wringer, like one of those things that you used to wring your clothes with, except it's for printing on paper with etching plates. So anyway, I decided to start on the, instead of starting in the middle of the machine and kind of working my way out, I want to develop the drive system because I'm using kind of a unique cycloidal drive system for the press. So it's actually pretty photogenic, the whole drive mechanism. So I'll be building the full drive mechanism and testing it on the bench prior to installing it on the machine. Anyway, this is the start of the hand wheel here, and these are just flame cut steel parts here. I drew it in on the computer and then just sent electronic files to the steel supplier, and they cut the parts out for me. This is 1.5 inches thick here, and I machined the outer and inner profile so that I have an accurate circle, and that's the problem, or well, not the problem, but what we're addressing now. The wood you see underneath here is an assembly fixture, and you might say, gee, a wood assembly fixture, that sounds kind of wimpy, right? Well, this isn't a heavy-duty welding project. Yes, I'm going to weld all these joints, right? But the pieces are big and heavy, and they don't distort a lot when you do light welding on them, or lighter welding, I should say. What's most important is that the initial alignment of those components is really accurate. So here's the scenario. Excuse me. You've got this thing on the machine and you're spinning this hand wheel, right? Well, you don't want to see the hand wheel going bloom, bloom, bloom and lumping around sideways or bouncing up and down vertically, right? It's going to make for a crappy looking hand wheel, right? So you want to spin this thing, and it wants to, be running true and as true as we can make it. Let's put it that way. I don't expect it to be perfect, but it's worth the effort to put a little assembly fixture together. And so that's what the wood's about. So this is the base, and there'll be some clamping elements here to clamp between the sections, and this will assure that the thing gets lined up with an equal radius and all the way around, and some of those other things. I'll bring it in a little closer to show you some of the details as we get into it. And this is all being modeled in SolidWorks here. We have some drawings that I made. So anyway, we got some layout work to do initially on this, and then there's a temporary center hub to help support these the curved arms here, and these have an internal radius here. And then there's some curved blocks. Anyway, it's a bunch of work, so it's all fun stuff. We get to do some layout with Trammels and rulers and things like that, so that'll be kind of fun. So let's get to it. Okay, so here's our drawing, and this is just for reference here. This shows the diameter and the radiuses, and then it's got some details about the actual drive hub that'll get welded into these arms. Before we install the actual drive hub, I need to make a kind of a temporary fixturing hub here, and this will engage with the wood, and it'll support the arms at the correct height for the welding assembly. So, and this will be made out of aluminum, so no weld metal sticks to it or anything like that. So we'll make that piece on the lathe. But right now we're going to do we're going to do a little bit of layout on the wood here, some diameters and some other things to help us get the fixture set up. All right, so we got our big ruler out. This is our big 8-footer here. We're just going to locate the nominal center of the sheet here, just to establish a point in the center that we can operate from. I'm lining one up, and then the other one's, I don't know, 4 feet away or more. Like I said, I don't really care, other than I just kind of want the nominal center of the sheet. Okay. We got our Trammels, and so I think first let's keep it simple. Let's just put the OD there. And that's a 48-inch OD, so we need a 24-inch radius. Let's start there. Run this one out a little bit. So I'm going to burn an inch here. That way I can get the point of the trammel in the 1 inch there. And then slide this back. And just get it close to the 25. And then I can, oops, closer than that. And I can lock this. Yeah, not quite close enough. Let's try that. Okay, and then this point here, it's actually ground eccentrically, so all I have to do is rotate it a little bit, and I can do the fine adjust here. And then I'm just gonna sweep a little bit of a line to make sure that I'm right on the 24 there. Okay. This out of the way. Okay, so this little oop. Alright, so I got a good center thing. Alright. That just made it. Oh, okay, that's just a whisker over the edge. Now this is a piece of, it's like subfloor plywood. It's pretty thin, it's 200,000 thick, something like that. Alright, okay, there's our OD. And this just barely kissed off of the edge on that side, but that'll be okay. That's not going to hurt anything because it's so close. If it was way off, I'd be worried there. And then I'm going to go ahead and mark the ID also. Too many measurements rarely hurts. So what do we got? 22 3/4. Okay, I gotta move it a little bit. Okay. Yep. Okay, inside and outside. All right, so I don't know if you guys noticed, but the rim is broken up into 5 segments, and so I have to make sure that the joints between the segments are accurately aligned, and that's the idea of this fixture here. And that radius looks pretty good. Oh, this has still got a little edge on it that needs to come off. Oh yeah. Okay, that's looking pretty good. So I'm going to cut some blocking to fit into these different areas here to secure the segments. And then we'll turn the aluminum center hub that goes in the center there to support the arms. Okay, so we're working on the hand wheel here. So what I did was I cut some cleats here, and this is 3/4 13 ply Baltic birch marine plywood. This stuff is like the aluminum of wood. It's real dense, and it's bonded really well. It's not like normal plywood. Anyway, you can see I have a radius marked on there, and I've bandsawed it a little bit large. So what we're going to do is we're going to belt sand that nice and square and right to the radius. And then on our layout lines here, we're going to go ahead and mate that up on our layout lines, and then I'm just going to attach it to the base here with some small finishing nails and a little bit of glue. And then there'll be a bunch of these cleats around there. I need spaces in between for the arms of the hand wheel to pass through. So I'm going to go belt sand these curves and get them nice. I may pre-drill some holes for the little finishing nails just so I don't have to hammer so hard because I want an accurate positioning there too. I'll clamp them at the same time also. So okay, so I need to lay out the positions of the arms, and they happen to they coincide with the seams of the segments. So I'm just going to lay out the 5 joints here. So I can position the cleats without interfering with those. So, you know, I got a nice square here, so a good idea is kind of workman-like practice. You know, basically I could just draw a line anywhere and start and work my way around. But I got this nice orthographic square, and I've kind of started with that. So I'm going to put one of the seams, you know, perpendicular to the world here. And there's no particular reason. It's just, you know, I have a choice, I guess, is what I'm saying. And when you have a choice like that, you know, there's no particular reason to not do it either, right? And something that may not be obvious to me right this minute as I'm working on this might show up later on, and it was a good idea that I put that seam excuse me, perpendicular to something, okay? So that's my starting point. I'm just going to put that right there, and then bring this up, match my curve. Like so. Okay, now I could just kind of work my way around with this, but this thing's kind of heavy. It's steel. So I think what I'm going to do is I'm going to pick this point and this point here and use that distance and just step it around with my trammel. So this will fix that distance and make it well, it still would be cumulative, any error, but it would be from me well, the distance is fixed, and then I got a nice point. It's still a cumulative error. So if I work my way around, okay, so my pencil's getting dull too. I hate it when my pencil gets dull. What was I going to say? Oh, so when I step this distance off, okay, what I would expect to see if I'm like perfect and nice is the last one intersects with that. That probably won't happen, and I'd be kind of surprised if it did. But we'll see what happens. I wish these mechanical pencils fit this thing. That would be really nice. So I should look for a mechanical pencil that fits these Trammels, and then I don't have to keep sharpening the damn thing. So yeah, we'll do it the old-fashioned way. This thing's not sharp enough. I'm going to go sharpen it with the regular. Okay, I found a pencil that has a harder lead in it, which is probably part of my problem there. So I'm just going to sweep a little light arc on that, and then I'm just going to pick that up again. And just a little mark. Alright. Then I'm going to reverse the direction here. Okay, so it's not bad actually. It's pretty good. We call it a cocked hat, which is what that is an intersection. Let me draw this. So you got an arc. So you got an arc one way, and then you got an arc the other way. So this little bit in here, we call that a cocked hat. It's actually from navigation, and it looks like a funny little witch's hat or something like that. I'm not quite sure how it got that name, but you see it in navigation where you have lines coming in from different bearings, and you're finding your location. And if they all line up, that's actually kind of frightening because it almost never does because there's little measurement errors. So the smaller the cocked hat, the better you feel about it. Anyway, so that layout came out pretty good. So we're going to draw some lines. So we're just going to draw lines from the center. So I stick my pencil in my prick punch hole, or my little hole there, and now I'm just going to drag those lines out. Get that one. One more. Okay, so those are the spokes there. Okay, so what I want to do there is I want to go ahead and just put a reference circle on here that meets up with this arc. And we're just going to do that with the Stare at 92 dividers here. These are my favorite dividers in the universe. They hold a pencil, they hold a scriber, you can get divider legs for them. There's all kinds of neat stuff you can do with them. I made a little thing for them to hold a Sharpie even. Because the Sharpie is the metalworker's friend. All right, let's verify that. Okay, so that's 3 inches. All right, So now, theoretically, should be able to put that kind of like that. And that's kind of how this thing goes. Something like that. So now I can position my cleats at the other end real well, and so that I can clamp the rim to it. So I decided to just go ahead and mark these and define them a little bit better with a Sharpie here. It looks cool, and who knows, keeps me from having to handle these things a whole bunch of times. I've got a center line on this here that I'm looking at, and I'm splitting the, I'm lining that up with my my center radial line there. And all this is just a something I can kind of push against just slightly to have an edge, and that way I don't have to look at it to line it up. This shouldn't be, these arm lines really shouldn't be, they're not a precision part of the layout. And this reminds me of sheet metal pattern drafting, you know, which is kind of fun actually when you get into it. Doing transitions and different sheet metal shapes where you have to develop the patterns. It's kind of fun doing it once you kind of get the hang of it. All right. I think I killed the point of that Sharpie, yeah. You know, this flame cut edge here is kind of rough, so my Sharpie's a goner now. Alright, so we're ready to turn this little boss diameter. It changed one number a little bit, so it's not a big deal. So what I want to do is I want to put a little witness mark on the on this, so I know when I'm getting close to that 1 inch. So what I'm going to do is I'm going to come up, and I established a datum or a touch off on the outside here on the dial. So I'm just going to count turns in. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. So that should be an inch there. And I'll just verify once again with my scale, and I'm just looking at the pip on the middle there, and yeah, that looks like an inch there. So what I'm going to do is just I'm just going to put a little, same thing, a little witness mark like that, and then I'll back up, and now I'll establish my my touch off there. Okay, and my new depth is 144 thousandths. So now for this, since it's such a short length in Z, I'm going to put the feed rate real slow so I don't jump up on it real quick. Alright. Also, I got a pretty good grip on this now. So, you know, I can do that's a 1/4 inch depth of cut there, or on the diameter, and it's probably fine. These chips here, these are kind of sharp, so you got to be careful with those. Give it a little spritz. Okay, so this next one is my last cut, and so I'm going to come up short of that that diameter, and I'll take a measurement. Okay. Yeah, okay, here we go. Okay, and it's not hot, so I'm 1 inch 034, and I want 1 inch there. So I'm going to take 10, 20, let's do 20, and then I'm going to face off of that, and then we'll come back and do our finish pass. That's going to get rid of all the steps, and I'm within 3/1000ths of my my finish Z dimension there.
16,000, 16 and a half. Okay. Let's do it. Oop. Let's do a little depth there, just for ha-has. Yeah. Okay. Oh, I thought that was the finish. Did I read that wrong? Well, it's still got 10 thousandths on this diameter, huh? Okay, whatever. Okay. It must have been backlash or something. Alrighty, there's 1 inch. So, and then once again, I'm just gonna break those edges a little bit. See what's my so how thick is this rim here? It's supposed to be, oh, I don't have that dimension on there. 435. Okay, all right. Okay, so I think we're ready to poke a hole in our our assembly fixture. All right, so we're ready for a little gluing here. I don't want a ton of glue under here. you don't need much. Probably need a little more than that, but otherwise it acts kind of like grease a little bit when you're putting it down. And I'll try this first one and without clamping it and see how it goes. I've driven these through, so they're just ready to pop through and go into the base material here. Yeah, that works fine. Yeah, you just got to give it a decisive little hit, and you know, I'm just knocking them through until I just feel the table underneath. And get this out of the way here. Oops. Suppose I had to prep all these pieces. And I'm just using a little brush here to spread this glue out so that it's the surface is fully coated. Otherwise you got to spooge a whole bunch of that on there to make sure you cover it. I don't want a bunch of excess, like I said. And I want clearance on the side here. Yeah, that one I got a little too much glue on. Gonna hold that down nice and gingerly. Okay. And I can cut those off later on, get them out of my way. Anyway, I got a bunch of those to do. I'm not gonna bore you with that on the video. And so I'll get that set up and we'll come back. Okay, so we got an aluminum blank here, and this is our little temporary center hub, so we can tack the arms together and you know, get a good registration there. So I got to do a little turning on this, but this is kind of a narrowed aspect ratio, so it's 4:1 here. So well, it's a little over an inch, but that's 4 inches. So, you know, it's pretty easy to get that cocked in there. So what I use is this spider, and this just goes in here somehow, like that. And then what this does is it just spaces me off of the back of the vise parallel there. So what I'm going to do is just take a little facing cut on that, and then I'll flip it around. You know what? Actually, that's a saw cut on both sides, so let's do this a little different. What we'll do is we'll push it in almost all the way, and then what I'm doing is I'm bringing the vise down till it just touches it's touching the OD there, and I'm rotating it, just clocking it slightly to get it to bear evenly on those jaws, and then it felt soft. There we go. I give it a little spin, and then there you go. That's better. See, and this feels, the chucky feels hard when I tighten up on it. So I'm just going to take a little skim cut on that. Just to face that off. This is what, 510 RPM, and I don't know, it's probably about 15,000 speed rate, something like that. All right. So that gives me a good, a nice registration surface there for my spider, so I can hang it out a little bit. Now Mr. Spider will go back in. Okay, and then my freshly faced surface will go against that. And then I gronk on that. And just for good measure, I'm just gonna, and this is just a little copper bopper here. So this is copper that's been run through a furnace and made basically dead soft. It's not quite as soft as lead, but pretty close. And because it's a little bit springier than lead, they kind of last a little longer. They're not, you're not rubbing lead off on your hands too. So, okay, so there's that. Let's do the same thing on this end. I'm going to establish a datum. For light aluminum cutting like this, I just use a little bit of WD-40. It's mostly kerosene with a little bit of lubricant in it and then some scent, but it works good for light cutting on aluminum. And I can kind of shoot it on from a distance, instead of reaching in there and brushing. Alright, so that looks like it's cleaning up. I'm going to set my 0 here on my Trammel. Okay, yeah, so that cleaned up. Okay, so check the drawing. What are we doing on this side? So this is going to be the 3-inch side, and I'll show you the drawing again here. So we're going to do the 3-inch side first, because then that gives us a nice thing to hold on to do this backside stuff. Okay. Let's see if I got enough hanging out. Oh yeah, I got enough hanging out. So I'm zeroed, and my first number, my Z depth in this direction is 1/16, 1/065. So let's go down there, and there's 1/065. Okay, and then I just do a quick sweep here, make sure nothing's touching. And all I'm going to do is just put a little witness mark on the stock there, like that, and then that just kind of gives me a little visual target mark. So I know where I am. Okay, so then I just touched off on the OD there, and I'm going to set my dial. I know that's 4 inches, and so I got to take an inch on the diameter off. Okay, so now I'm not going to rip and tear on this, because I'm only holding on to whatever that is. 5/16 of the end of that. It's a 6-jaw. I got a pretty good grip on it, but hey, you know what? It'd be embarrassing to flip this off on video, and then have to fess up to it, right? All right, so let's. I'm just coming up close to my line. So that should be about a ½ inch off of the diameter, and we'll verify that before we get too carried away here, right? Yep, 3.5, okay. So, you know, I'm using my, and I advocate this, I use my dumbest measuring tool when it's appropriate. And the reason for that is, you know, you make less mistakes. So if I measured this with a micrometer, right, which is fine, right, but you're reading it to a thousandth or something like that, and you might miss a turn or miss a hundredth or whatever, right? With this, you know, this is pretty easy to see where the heck you are, right? And then, you know, as I get closer to the 3, obviously I'm going to switch measuring tools, but this just, you know, keeps me honest here, and you know, I find that it prevents you from making mistakes if you're using your scale a bit. So, all right, keep going here. Okay, so I'm getting close. Oh, that's a 1/4 inch. Yeah, never mind. Close now. I'm taking a little bit lighter cut to reduce the tool pressure, so I don't have any spring back. All right, time to get a real measuring tool here. All right, let's see what we got here. So we got about, yeah, 48, 46, and about 46 thousandths left. 20, 30, 40. so what I'm going to do, actually let me turn that off so you can hear me talking. So you can see here that I've been stepping my way down, dun, 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 dun. And so this surface is kind of unfinished. So right now, this is the pass right before what I think is going to be the finished pass. So what I want to do in this situation is I want to get some of this garbage off of here and get a little closer to my finished Z number. That way, for my final pass, I can go down, or turn the diameter, come into the corner, and then face out, and then I'm done. And that way, I don't have to re-pick an edge or come back on top of it or do anything like that. It's kind of the last hurrah there. Okay, so what I'm going to do right now is just kind of come in closer to my finished Z number, and then face out, and then come back and do my finish pass. I'm going to come out, hog off some of that, so that evens that surface up real nice. Okay, now come back out. Okay, go back to my number. I'm actually going to measure it just to double check where I am. I should have about 5 thou left. Saying a little more than that. Okay, that's okay. We'll take the 5. We'll take the 8 that it's showing, and then we're going to come up to our finished Z number. Now this thing, I'm not worried about the surface finish on it. It's just it's going to get all buggered up from the welding. Okay, so let's check it and see what we got. Excuse me. Well, it's showing 1.5. Crap. I just ate a Snickers bar and I got some peanut dust in my throat there, so excuse me. Let me get a micrometer there and see what's going on. So that's showing 1.8 thousandths over. You know what? I'm not gonna fart with it, I don't think. You know what? Let's just go ahead. I mean, it's not a big deal. We'll just get it right on the money. And while I'm at it, I'm gonna slow my feed rate down a little bit. Okay, pretty happy with that. Let's double check the depth here. Yep. Okay. Good. So I think I'm just going to put a couple little chamfers on that. So now what I want to do is check my drawing, because I was getting all excited and I was going to pull this out and flip it around for the next thing, but there's a little hole I forgot about in there. So before you remove something from the chuck or the vise, just pause for that little second and go, okay, is there anything else I need to do in this setup, right? Because it's a lot harder to put it back in there and get this dialed in again to do this one last thing that you might have forgotten, right? So it's a good idea to check the drawing, just take a deep breath and go, yeah, that's it. Or, oh, hey, wow, I forgot the chamfer, I forgot the hole, or whatever it is, right? Anyway, just good practice. Okay, so this hole, it really doesn't actually have a function, but while I have it in the machine, I thought that I might end up using it to attach an indicator to later on to sweep the OD of the hand wheel when I check it. So it's pretty easy to put it in now, and if I don't use it, fine. And if I do use it, then I have something there that a nice feature that's kind of right in the center. So anyway, that's what this hole's for. But like I said, it doesn't actually have an intended use. It's just a theoretical future use, I guess. So we're ready to flop this thing around here. Get that out of there. We don't need that anymore. So in this case, I'm going to bring it down to the that diameter, get it close, and then just push it right up and register against those jaws, and just give it a little snug. And then first thing is to establish the thickness here, 1.442. Okay, and yeah, okay, that's interesting. So this little slug, it's a little below what it's 40. It's 60. It's a 16th short of my what I drew. So we got to do a little compensation there. I didn't saw that slug off with enough extra stock. No biggie. It doesn't really matter. What's important is the from this inner surface here to the surface that sits on the template there. That's what matters, and so we'll be able to compensate for that. All right. All right. So we're ready to turn this little boss diameter. It changed one number a little bit, so it's not a big deal. So what I want to do is I want to put a little witness mark on the on this, so I know when I'm getting close to that 1 inch. So what I'm going to do is I'm going to come up and I established a datum or a touch off on the outside here on the dial. So I'm just going to count turns in. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. So that should be an inch there. And I'll just verify once again with my scale, and I'm just looking at the pip on the middle there, and yeah, that looks like an inch there. So what I'm going to do is just I'm just going to put a little same thing, a little witness mark like that, and then I'll back up, and now I'll establish my my touch off there. Okay, and my new depth is 144 thousandths. So Now for this, since it's such a short length in Z, I'm going to put the feed rate real slow so I don't jump up on it real quick. Alright. Also, I got a pretty good grip on this now. So, you know, I can do that's a 1/4 inch depth of cut there, or on the diameter, and it's probably fine. Now these chips here, these are kind of sharp, so you got to be careful with those. Give it a little spritz. Okay, so this next one is my last cut, and so I'm going to come up short of that that diameter, and I'll take a measurement. Okay. Yeah, okay, here we go. Okay, and it's not hot, so I'm 1 inch 034, and I want 1 inch there. So I'm going to take 10, 20, let's do 20, and then I'm going to face off of that, and then we'll come back and do our finish pass. That's going to get rid of all the steps, and I'm within 3/1000ths of my my finished Z dimension there. we got here? 16,000, 16 and a half. Okay. Let's do it. Whoop. Let's do a little depth there, just for ha-has. Yeah. Okay. I thought that was the finish. Did I read that wrong? Well, it's still got 10 thousandths on this diameter, huh? Okay, whatever. Okay. It must have been backlash or something. Alrighty, there's 1 inch. So, and then once again, I'm just gonna break those edges a little bit. See what's my so how thick is this rim here? It's supposed to be, oh, I don't have that dimension on there. 435. Okay, all right. Okay, so I think we're ready to poke a hole in our our assembly fixture.